Welcome again. This is Fred, and I'm going to be teaching you robotics. And yesterday we were talking about LED. So, what is an LED? LED basically, we said LED is a light emitting diode. So, it's a component. It's the simplest component in electronics whereby it emits light. So, for any beginner, you must learn how to use LED. What is it? And what are the specifications of that LED? So today we are going to continue with that and also add some other content on LEDs and what projects you can build. We are going to also see the projects you can build using LEDs and also advanced projects with LED. So make sure you follow along this series of Arduino robot and robotics masterclass, and you're going to learn a lot. So we said LED stands for light emitting diode. So that is the LED. So basically LED is a diode which can emit light, and from physics, a diode is something like this. It's a device that will allow uh, voltage or power to pass in one direction, whereby this is usually the anode and this is the cathode. So from chemistry, we know this is negative and this is the positive. But now, actually, this is a diode. And now, what is our LED? The symbol for a LED is usually it has these two arrows. So the difference between this one is arrows, yeah, because we are going to emit light from the diode. So it's a light emitting diode, but this one is a diode. This one is it's emitting light emitting, light emitting diode. Yeah. Then we have another symbol for LDR. LDR LDR is a light dependent resistor. Okay, this is it's a bit advanced. We're going to tackle it in later chapters. So we can say it's a resistor which depends on light to determine its value. Like for example, if you want to achieve like 10 kilo ohms, there's a certain light you need, yeah, certain intensity of light you need. But now our interest is with light emitting diode, this one, that is our interest, light emitting diode. So we said light emitting diode, its initial is LED, and you have to understand the pinout. The pinout of any component you are going to use, like for example, let's assume you want to use a sensor like DHG11, you have to understand the pinout. Pinout is basically pin configuration. Yeah, like for example, LED has two pins. Number one, we have the negative and we have the positive. So you have to understand which pin is negative and which pin is positive. Like for instance, our LED here, you can see we have the shortest pin and the longest pin. So the shortest pin is usually the negative and the longest pin is the positive. We have around 5 ways we can identify the pinout of the LED. Let's assume maybe you have soldered the LED from a PCB, or maybe you are given LED which has its pins or legs which are equal. How are you going to identify which pin is positive and which pin is negative without destroying the LED? Yeah. So basically, we have five more. We have around 5 ways how to identify. So I've given you that as an assignment. You can comment there below on how do we identify the pin out of the LED. So again, you need to understand the technical specification of the LED, like the power rating rating of the LED. Yeah. So how much voltage should I supply to the LED? How much current should I supply to the LED? What is the minimum voltage and what is the maximum voltage I can supply to the LED without destroying it? Like for example, most of the LED they are rated at 2.8 volts to 3.2 volts DC. Basically, it's DC. We are dealing with DC low voltage, around 5, yeah, less than 5 volts. So basically, you can power your LED with 5 volts DC. As you know, Arduino has 14 digital pins. And sorry, they range from 0 to 13. In total, there are 14. And these pins, they are 5 volts tolerant, meaning they can supply 5 volts to our components. So in binary, okay, in this world of a digital world, we only have two states, which are zeros and ones. If we pull any pin from 0 to 13, any of the 14 pins high, or we address it as 1, that means it's going to supply 5 volts. If we address it to 0, it's going to supply 0 volts. Yeah. And for instance, you have connected your positive pin to the digital pin. Actually, that is what you are supposed to do to the digital pin, either from 0 to 13. That means you're going to supply 5 volts directly to the LED, and your LED will burn out. Yeah, it won't work because you have exceeded this limit. You are not supposed to exceed this limit. So, what are you supposed to do? You are supposed, now we are going to introduce another thing called current limiting resistor. So I want to draw the basic circuit everyone needs to understand before you enter into the field of robotics. Yeah, you have to understand this basic circuit. If you don't understand how it works and what it achieves, then you can't thrive in robotics. In fact, you can't do anything to do with robotics, even if you know how to code that. So we have two types of circuits. We have open circuit, and closed. So what is the difference between open and closed? So I'm going to draw here open and closed circuit. So let me just use one cell. So basically this is the positive, this is negative. And again we have another circuit here. Of course it has a battery for supply. Again positive and negative. The longest one is usually the positive. So this one A is closed and B is open circuit. So basically current will flow from the positive to the negative via a load. This is called an electrical load. Even this one is a bulb. Basically is a load. A load is any appliance or electronic which when plugged to power will draw some power from that supply. Basically can be electricity or maybe DC source. So this is the open and this is closed. So this means there's a gap here. So electricity can't flow through a vacuum or a gap. It needs a closed circuit. Yeah, and also you need to understand good conductors and bad conductors of electricity. Yeah, for instance, these are connecting wires, maybe copper wire. So once you understand the working of this circuit, now we are going to implement a microcontroller, which is, for instance, is our Arduino, to replace this switch. You see this switch, we're going to replace it with a microcontroller. Instead, okay, let me go back a bit. Let's assume our voltage supply here is 5 volts, 5 volts. In this case, if we close the switch, our bulb won't work again. It will blow because we have supplied a bulb or a switch, or an electrical load which is rated at, let's say, 3 volts, 3.2 volts max, 3.2 volts. We have supplied 5 volts to it, so it will blow. So for us to avoid that, we are supposed to introduce something which is a current limiting resistor here to resist excess voltage from reaching to the bulb. So if we use, for instance, let's assume if we use 330 ohms, it's going to, according to physics, now there's some calculation. I don't want to enter into calculation because this is among our first class. So let's assume if we use a 330 ohms resistor, we are going to get at here, we are going to get around, we're going to get 2.9 volts. Yeah, still our LED will turn on, but it will be so not that bright. But let's assume in another case scenario, we are going to use around 220 ohms. So this one, it's a bit lower resistance. So it's going to allow relatively high current or voltage to reach our electrical load. So let's assume once we do that, we are going to get, for instance, we're going to get 3.1 volts. This is just an example. I know using mathematics and some calculation and some formulas like V equals to IR, we're going to get it won't come to 3.1. We're going to get more realistic values. Yeah, this is just for demonstration purposes. Yeah, so basically, yeah, so our bulb, let's assume this is A and this is B. A will turn brighter than B. That means you need to calculate well your resistance, the value of resistance you are going to use for certain components. For instance, we are talking about LEDs. So that means there are some resistors we can't use for LEDs, and there are some resistors which are suitable for LEDs. So that being said, I can just recommend one. We normally use 220 ohms for LEDs. Still, you can also use 330 ohms for LEDs, not more than that. Sometimes some people can use 1 kilo ohm, but your LED will be so dim. Yeah, we have other values, other higher values, but you can't use them. We have other like 10k ohm. We have 4.7 kilo ohm. We have more than that, even 100 ohm. Now, yeah, you can't use these ones. You can't use these ones. These are very high. They are very high values. Yeah. Also, still on that, there are some resistors you can't use, which are very low. Like for example, we have 10 ohms resistor. So you can't use this one. If you use this one on a 5 volts, it won't resist much current. So maybe if you use this one on 5 volts, you're going to get 4.8 volts. Still, this has exceeded 3.2 volts current, limiting the specification of that LED. So that means our LED will still, oh sorry, this is 4.8. Our LED will still blow out because we have exceeded that value which is rated by the manufacturer. Yeah, are we together? Now, uh, now when we come to Arduino microcontroller, we are trying to replace the switching on and off using the manual switching on and off. So we are going to replace the switch with a microcontroller. That is what we are going to. I'm going to show you how to do it. So in the next class, we're going to talk about switching on and off of the LED, but not manually, but using a microcontroller, and that code is usually called blink. Blink is just basically a blink again. So that is blink. You turn on the LED and off, not your eyes. Turn on LED and off. Basically, the I told you in the last class that the most common code in any programming language is called hello world. Basically, if you have learned any programming language like C, C++, Python, Java, JavaScript, HTML, you have probably done Hello World or wrote a code called Hello World as your first code. But now, when you come to electronics and embedded systems, we don't have, okay, we have Hello World in electronics, but now ours is called Blink. You turn on LED on for 1 second, wait for 1 second, then off, wait for 1 second, like that. Yeah. So that is what we are going to do. So we are going to learn about Blink code. We can say Blink project because we are going to code and also build the project. Yeah, so see you in the next video. Make sure you subscribe to my YouTube channel. Also make sure you share and you follow me on TikTok at Mr. Arduino. That is my TikTok account. Goodbye.